In this video, we're going to be discussing proportional versus non-proportional. Now, your foldable for proportional or non-proportional should be glued at the top of page 7. So let's first talk about proportional and what non-proportional means. So when we're talking about proportional means that your graph is linear. And when we mean linear, that means that it forms a straight line. Also, in order for it to be proportional, it has to go through the origin. And remember, the origin is 0, 0. So here our graph will cross this point. And lastly, it has to be in the form y equals kx or y equals mx. Now, again, if it is proportional, it goes through the origin. So an example of a linear proportional graph would be here. For instance, we see that it goes to the origin. Or, for instance, here, I have a negative graph, but again, it still goes through the origin. So this is proportional. Now, looking at a non-proportional means that it is non-linear. So this means that your graph might curve. Now, if it is linear, but it does not go through the origin, that makes it non-proportional. So for instance, if its y-intercept was 2, -3, automatically, since it does not go through the origin, that makes it non-proportional. And non-proportional equations are written in the form y equals mx plus b, where here you do have adding and subtracting. So here, an example of a non-proportional equation, for instance, here it goes through the point 0, 2. Since it does not go through the origin, that automatically makes it non-proportional. Also, we talked about it being nonlinear to where it curves. So let's say, for instance, it did go through the origin, but it curved. Because it curved and it was not a straight line, that means it's non-proportional. So distinguishing between the equation specifically, here we have no adding. I'm just going to put no add slash subtracting. And in the y equals mx plus b form, you will see adding or subtracting in the problem, in the equation. So let's keep talking about this a little bit more. So let's distinguish between proportional and non-proportional equations. We kind of already touched base on that. So here it says a proportional equation can be written as y equals kx, where k is the slope or the rate of change. Now, you can also use m for k. So whatever you want to do, y equals kx or y equals mx, it stands for the same thing. Now, in a non-proportional equation, this can be written as y equals mx plus b, which we talked about yesterday, where m is your slope and b is not 0. So, for example, your y-intercept might be 2, -3. Those, if it does not go through the origin, it is non-proportional. Now, when we're looking at graphs, any graph that is linear, like we discussed, it forms a straight line and contains the origin, will be proportional. So here on this line, it is a straight line and it goes through the origin, which makes it proportional. Now, when we're discussing non-proportional, any graph that is not linear or does not contain the origin. So in this example, our graph is linear, but it does not go through the origin, which makes it non-proportional. Now let's look at the table. So in the ratio of y divided by x is constant. If it is constant, that means it is proportional. So what I mean by constant is that when I divide y by x, it stays the same. So for example, when I take 6 divided by 2, this equals 3. When I take y 12 divided by 4, 12 divided by 4 is 3. When I take 18 divided by 6, we get 3. And when I take 24 divided by 8, that equals 3. Now let's look at a non-proportional table. So in a non-proportional table, the ratio of y divided by x is not constant. So this means that they are different. So when I divide y by x, I should not get the same thing. So for example, when I take 8 divided by 2, this equals 4. And when I take 14 divided by 4, let's plug that in our calculator to see what we get. So 14 divided by 4, we'll get 3.5. So here we already see that they are different, but just to double check, let's keep going. When I take 20 divided by 6, we get 3.3 repeating. So based off of this alone, we see that anytime we divide y by x, it is different, and that's what makes it non-proportional. Now let's look at word problems. So, in order for a word problem to be proportional, values given can be combined to form one unit. So, for example, here it says renting a venue hall for $20 per hour plus $15 per hour. Now, remember, words like per, each, every, those are words that indicate X. So, here I see $20 per hour and I see $15 per hour. And they are both representing hours as well. This is both monies per hour. So the way I can write the equation for this is 20x for $20 per hour plus $15 per hour. And I can simplify this because 20 plus 15 is 35x. So again, this is where it can be combined. However, in non-proportional word problems, values can't be combined to form one unit. Now, there was a typo here. This should say purchasing $4 per bottle of shampoo plus $2 to ship. The per bottle should not be there. So, this is what we are working with $4 per bottle plus $2 to ship. Now, again, words like per, each, every, those are words that indicate X. So, here I have 4X plus the $2 to ship is not for every bottle. It is just to ship the entire order. So this is 4x plus 2. And again, since the 2 does not have an x, this cannot be combined. So that is what makes this word problem non-proportional. Now let's go ahead and look at a few examples. So let's go ahead and look at number 1. So number 1 says Hannah reads at a constant rate of 2.5 pages per minute. Which graph represents the linear proportional relationship? So since this says it is a proportional relationship, that lets me know that if I'm looking at a graph, my graph should be linear and it should go through the origin. Based off of that information, I can eliminate B and I can eliminate D. Now, I have 2.5 pages per minute. So now I want to go to each of my graphs and I want to go to 2.5 pages and I want to see, does my graph go through when it is 1 minute? When I look at A, when I go to 2.5 pages, 1 minute, my graph does not go through that point. When I go to 2.5 pages in a minute, C does go through that point. So C is my answer. This is the graph that represents that Hannah reads at a constant rate of 2.5 pages per minute. Again, when I go to 1 minute, I see that she is reading 2.5 pages. Let's continue. Let's look at number 2. So for number 2, it says which table shows a non-proportional relationship between X and Y. So on a table, to determine if it is non-proportional or not, remember we divide Y by X. Now when we look at F, I see that I have, remember, on a table, whenever X is 0, whatever Y is, that is your Y-intercept. So since I see that I have a y-intercept of 0, 1, this lets me know that this does not go through the origin, and this is automatically non-proportional. But to prove it to you by doing y divided by x, I'm going to take 2 and divide it by 2. When you take 2 divided by 2, it gives you 1. When we continue, 3.5 divided by 5. 3.5 divided by 5 gives you 0.7. If I continue, 5 divided by 8. When I take 5 divided by 8, you get 0.625. So here I see that they are all different, and again, this table is non-proportional. So when you look at a table and you see the point 00 like G, H, and J, this lets you know that this is a possibility that it is proportional. But again, you have to check the table by dividing y by x. So for example, G, when I take 2.25 and divide it by 1, I'm going to get back 2.25. When I take 9 and divide it by 4, in your calculator, 9 divided by 4 gives you 2.25. And when I take 22.5 divided by 10, in your calculator, 22.5 divided by 10, again, is going to give you 2.25. So here I see when I divide y by x, I end up with the same number, which makes this table proportional. Now looking at h, again, I'm going to divide y by x. So 1.5 divided by 3. When I take 1.5 divided by 3, I get 0.5. When I take 2 and divide it by 4, I'm going to get 0.5. When I take 3.5 and divide it by 7, it equals 0.5. So here we see when we divide y by x, again, this table is proportional. So I'm looking for the non-proportional table. H is not my answer. Now looking at J, 6 divided by 2 gives you 3. 9 divided by 3 gives you 3. 21 divided by 7 equals 3. So here, anytime we divide y by x here, we also get that it is proportional. So here, the only non-proportional table is table F. Let's go ahead and keep going. Let's look at number 3. So it says, which of the following equations can describe a non-proportional linear relationship? Now remember, equations that are non-proportional are written in the form y equals mx plus b. So here we see adding or subtracting in non-proportional equations. So looking at your question or your answer choices, the only one that adds or subtracts is going to be C. So C is the only one that is a non-proportional equation. Let's go ahead and keep going. Let's look at number 4 now. So for number 4, it says which situation represents a proportional relationship. So remember, proportional word problems, the values can be combined. So let's go ahead and look at this. For A, it says renting a karaoke machine costs $2.75 per day plus a delivery fee of $39. So remember, words like per, each, every, those are words that indicate X. So I have 275X. This word plus means I'm adding a delivery fee of $39. Here, they're not charging a delivery fee of $39 per day. It's just they're renting the karaoke machine for $275 per day. So here, these two values cannot be combined. So this is non-proportional. For B, it says renting a wedding venue costs $259 per hour plus a final cleaning fee of $95 per hour. They're not charging the $95 per hour for the cleaning fee. It's a one-time cleaning fee. So again, words like per, each, and every, these are words that indicate X. So I have 259X plus $95. I forgot the X. 259X plus 95. These values cannot be combined, so this is non-proportional. So I can cross out A and B so far. Looking at C, renting a moving van costs $305 per day plus a one-time relocation fee of $75. So again, words like per, each, every, these are words that indicate X. So 305X plus 75. So here, again, these variables cannot be combined, so this is non-proportional as well. So lastly, let's look at D. Looking at D, it says renting a hotel costs $95 per day plus a daily hotel occupancy tax of $14.25 per day. We see that the cost that they are charging, it is both per day, so they both should get an X. So here, this can be represented as 95x plus 1425x. So when we type this in, 95 plus 1425, we get 109.25. So here I can combine this and it equal 109.25x. And here that would mean that it is proportional and our answer is D. Now let's go ahead and look at number 5. So for number 5, it says which situation represents a relationship that is not proportional. So this means that my values cannot be combined. So looking at A, it says purchasing exotic spices online for $35 per ounce plus a single shipping and handling fee of $11.75. So for this, I have $35 per ounce. So that can be written as 35x plus a single shipping and handling fee of $11.75. There is shipping and handling fee is not per ounce. It's just a one-time fee. Here I see that these values cannot be combined, so this is non-proportional. Most likely we have already found our answer choice in A, but let's go ahead and continue looking at our answer choices. So B says purchasing diamonds online for $2,500 per carat plus a luxury tax of $375 per carat. Again, we see that the amount they are charging is applied to every carat. So per carat here, and we see per carat there. So this is indicating X, and this is also indicating X. So I have 2,500 x plus 375x. And since they both have x's, that means I can combine them. And when I combine 2,500 plus 375, I get 2,875x. Since I was able to combine them, this is proportional. Looking at C, it says purchasing almonds online for $8.15 per pound, plus a shipping fee of $2.50 per pound. Again, we see that the amount they are charging is for every pound. So these both get X's. So this can be represented as 815X plus 250X. And since they both are being charged per pound, that means I can combine the amount they are charging. And when I combine 815 plus 250, we get 1065X. So this equals 1065x, and this means that this is proportional. I can cross C out. Looking at D, it says purchasing online identity theft protection for 7 cents per day, plus a credit monitoring for 3 cents per day. Again, we see the amount they are charging is per day. So this is indicating that these are both X, and which ultimately means that we're going to be able to combine the amount they're charging. So I have 0.07x plus 0.03x. And when I combine 0.07 plus 0.03, we get 0.1. So here this is 0.1x, and since I was able to combine them, that means that this is proportional. I can cross D out, and A is the only non-proportional word problem to where I could not combine anything. So that concludes proportional and non-proportional.